Just give me a minute. Let's start. Yeah, I think we can start. Let me share my screen. Where's that? Okay, my screen is visible already.
No, it is not.
Okay, 1 second. I hope it is visible right now.
Yeah, it is
Yes, sir.
visible.
Cool, cool. So this is like a continuous of yesterday's session. So yesterday we spent most time on this discussion, right? Threads and connection, all these things. So now, yeah, we will continue from the yesterday thing. Um, so to- yeah, so this is about the logical architecture, right? Yesterday we start like from the front end, the connections from different application, and we see about the MySQL shell and this document DB with MySQL X protocol thing. And also SQL interface. We already aware we are already communicating MySQL with SQL interface, right? Now let's start when someone connected the MySQL and they are executing some queries. Okay. For example, a simple query show databases, right? Show databases, or they are trying to execute some insert, update, select, delete, whatever. Uh, no one can directly connect and they can execute, right? They can, but they need the proper access thing, right? Because like MySQL access is very granular, like you can even control the access like table level, uh, column level, and what they can do. Everything we can control. And also from MySQL 8, there is very much granular the privileges are, right? So if someone is trying to connect and they are trying to delete some data, but they do not have the delete privilege, MySQL will reject it, right? And also if someone connected the MySQL and they are trying to do some activity, they are trying to execute some SQLs, but if the SQL syntax is wrong, MySQL will reject, right? MySQL will reject, and it will give them error, like a kind of syntax error, right? Syntax error, and this privileges also will be validated whether the user have the right privilege to execute the uh, SQL or not. These all things will be done by the parser. Okay, parser and query translation object privilege phase. This phase. Okay, so parser will verify the SQL syntax, and when the SQL syntax is allowed, then it will pass, and then the privilege management that system that will validate whether the user have the privilege, right privilege to execute the statement or not. That will be validated. Okay, I think yeah, so Yeah, so you will get mostly this kind of error code. For example, whatever you type, 1 second, -m InnoDB MySQL. For example, show schemas, right? It is working. Instead of show schemas, I'm just giving show schema, then I'm getting the error, right? The error code is 1064. So these things will be validated by the parser. Okay. And similarly, select user, comma, host from MySQL dot user. Um, so here the test user is there, right? Test user. Let me move this. So show grants for test at localhost. Okay, so this query will display the current privilege for this user. Okay, so we will see this in our user management class. We will see this in deep. So currently, currently this test user have the select privilege on all the database and table. Star means all the database, and then dot star means all the tables. Okay. Now let me log in with this test user. MySQL hyphen u test hyphen p test 321, I think. Oh man, what is the password? Test 123. Cool. Test 123. Show grants. Okay, now I logged in with the test user. And now show schemas, use here, and select star from 3. Okay, and I'm going to trying to delete from um 3 where id equal to 1. I'm trying to delete one data, but it will MySQL will reject, right? MySQL will, one second, let me admit, reject. And this is the error code 1142, because I do not have the access to delete the data. I only have the access to uh, read the data. I have the select privilege across the database and tables. Okay. So these all things will be logically validated here. Okay. Once you enter into the SQL interface and you are trying to execute some SQLs, then the SQL structure will be validated, and the SQL privileges, I mean the user privileges, will be validated. Once that is validated, your SQL is fine and you are good to execute, you have the right privilege in place already, then what then it will enter into the optimizer stage. Okay, there the optimizer will define the right plan, right execution plan to execute the query. Okay, it optimizer will manage the index statistics. Okay, you have the different variables to enable it, and how granular we need to optimizer will keep it. We have the optimizer related settings. Okay, these are all things we will see. But yeah, here, yeah, once your query syntax validated, once your access is validated, then it will enter into the optimizer stage. Optimizer will check the it will define the right execution path, right execution plan for the for your SQL statement. Okay, whether the SQL have the correct index or not. If it will choose the right index to execute the query, it will decide whether the query needs to go with join type, range scan, or what. These all things will be decided by the optimizer. Okay, so once the optimizer define the plan, then it will come to the cache and buffers. So we have lot of thread-based buffers. For example, short buffer size, join buffer size, read buffer size, table open cache, right? Table definition cache, read R&D buffer size. There is lot of buffers and cache. The main goal for this thread-based buffer is to run the query maximum in the memory, okay, to not allow the query to go to the disk. Okay, so these are all the thread based buffers we have. So let's say if I am executing one order by query, okay, order by with join, okay, I am executing the query. The once the optimizer plan is done, when it will check the current order by, means there the short buffer size value will be applied, right? So if I have the right value for my short buffer size, if within that particular value the query can execute in the memory, right, it will keep the data in the memory. When it is more than that, then only it will go to the disk, right? For example, I have the temp table size, which is defined 16 MB megabyte, and I'm running one complicate query with group by some and some functions, okay, and the query is creating the temporary table. When the temporary table is less than 16 MB, until that it will be in the memory. But when it is more than 16 MB, the temporary table will be converted from memory to disk, right? Memory to disk. And whenever temporary table is in memory, it will be faster, right? It will be faster. When it is converted to the disk, you will face little bit slow comparing to your RAM. I mean memory, it will be slower, right? Anyway, everything in the RAM, it will be faster. When it goes to the hard disk, it will be slower comparing to your RAM, right? So this buffers and cache we will allocate the value for this buffers and cache, and we need to find the right value for that, okay, so that you can avoid the tables, you can avoid the operations on the not completely, but as much as you can avoid the operations to the disk. Okay, you can keep it run in man. I mean, you can keep it in the RAM itself, volatile memory itself. Okay, so that your you will get some good performance. Okay, so yeah, this is like we are seeing the logical thing architecture, so no worries, we will address all these variables later. Okay, in our performance tuning session we will address all this parameter and how to choose the right value. This all things will be addressed. Okay,
So
so
the
now,
memory,
yeah,
sorry, the memory which you are allocating is that InnoDB buffer full size parameter memory will it use or server memory will it use?
it will use the server memory. So we have two different things. One is the global memory and the thread-based memory. The global memory is the one we will allocate from the InnoDB buffer pool size that will be used for all the InnoDB operations. Apart
Okay.
from that, we have some thread-based values, memory allocation parameters as well, like all this buffers and cache and thread stack, all these things. This will consume the memory from your server, not the InnoDB buffer pool.
Okay.
So this
What
is
about
what
this
sometimes,
optimizer, parser, these objects also in this and the same memory?
yes, correct. So sometimes you may see like you configure, let's say you have some 60 GB of RAM, but you configure 40 GB of your InnoDB buffer pool, but your overall MySQL memory utilization is more than 40 GB, like around 50, 55. Sometimes it happens. You may feel that, experience that before. So that
Yes.
is yeah, that is due to there are, apart from your InnoDB buffer pool, there is lot of other things will consume the memory. For example, if you enable the performance schema, that will consume the memory apart, I mean, from your system. That will not use the memory from InnoDB. And you have some thread-based values that everything will be consuming the memory from your system. And you have the temp table, all these things are there. Temp table, max heap table size. This all will consume the memory from your system, not from the InnoDB. So yeah,
What about this parser and optimizer? These all are standard. This one, right? Objects, right? Actually, that dictionary objects.
huh,
Where
correct.
where these objects to verify that to parsing that syntax, there
Hmm.
is some dictionary objects are required. those objects where it will be stored, in which parameter or in which part of memory.
So we have one parameter which is the optimizer switch. So there
Okay.
we can control all this behavior. So for example,
Mm.
show variables like optimizer. Yeah, so here you can see this is the parameter. Here we can control the optimizer. So how it needs to create the plan, create the query plan. These things we will control from here using this parameter. So here you can see there are multiple values, right? Index merge, which is on. You can turn off the index merge. And this also can be done session level. Instead of applying the entire query, you can tune this for your single query, which can benefit from any specific value here. You can tune that as well. Anyhow, we will see this in our query optimization session.
These are not this that will be used from the host memory, right?
But
Server memory.
uh, s- I don't think this will not use much memory defining this plan. So we have the thread stack value for each thread creation. We have I think 256 KB for each thread when it is getting created. So
Okay. From
during
there.
that, yeah, using that, everything, I mean, this basic validation, all these things will be addressed. It will not going to consume your more memory. When it is entered to the engine or when it is started to execute the statement, then only it needs the memory. That will comes to your buffers and cache. The
Okay.
Well,
validation itself, yeah.
so in MySQL there is only one process. That's a MySQL process. Even InnoDB is a thread kind. It's not a separate process, right? InnoDB engine is also a thread inside MySQL process, the main MySQL process, right?
Yes.
What do you mean by InnoDB memory and server memory? Like they are, all of this memory is part of single process, so they are all common memory, right?
No. For example, let me show you. So here you can see select at InnoDB buffer pool size. Okay, so this is currently by default 128 MB. So this is the one. And apart from this, show variables like buffer. See, these are all the ignore the InnoDB, but here you can see join buffer, key buffer, all these things. So MySQL D is the process, right?
Mm-hmm.
Within that you have different thing, right? Like you can within that you have the sub process like not the Linux level. I'm telling within the MySQL you have different threads, right?
The threads, yeah, these are threads, not process.
Yeah, so here you can see this is the engine layer. So when all your InnoDB related operations, all your InnoDB related parameters, what you are allocated, that will be done by here only,
Correct.
right? Apart from this, you have one more layer, right? This layer. So for this layer, you have specific configs. This layer you have specific config. This layer also you have the specific configurations. So all your InnoDB related parameters values, whatever memory you allocated, CPU, whatever that parameter you set the value, that will be applicable only here. That is your InnoDB buffer pool size in your from your system memory. That entire memory will be allocated for only this process. Okay. Apart from this, we have this caches and buffer, all these things, right? That is for to execute your query when they are going to create some sorting operation or some temporary table or some complex join operation, whatever it is doing, they need some memory. Those memories will be allocated by the system itself, not from the InnoDB, because the query is still not entered into the InnoDB engine, right? You can see here. So once these all things are done, then only the query will comes to the InnoDB, right?
Yeah, that's fine. The which parameters will use which we set for using that memories, cache buffers or optimizer query. Where the see for optimizer, actually optimizer or parsing,
Hmm.
there is some dictionary objects. Okay, by using the dictionary objects, actually the query syntax will be checked. The dictionary objects, once you loaded that MySQL process
Hmm.
daemon, it will be this one store that dictionary objects in the sense the syntax tables will be loaded. Those where it will be saved in which memory. Actually, we understood the down part. Whatever we are allocating the parameter, the InnoDB, those all are for once that syntax error or a query optimization. These
Okay,
all
so you
things
mean like when you was
before entering to the storage engine, the query needs to perform some operations,
yes.
parsing, optimizing, or bringing data from a disk to and keeping in buffer cache. These are those. So for those objects or those actions need to performed in the memory only. Okay, these
Yeah.
all are yeah. Which parameter we allocate that memory? Actually, for which parameter we allocate that one?
The performance tuning is telling na, he will cover performance tuning, those parameters.
Yes, Siri, what I
Mm,
understood, like while parsing, it will check the syntax, like how syntactical error is there. That check where it will do before going to accessing the tables and all. That dictionary level, I mean, if grants are not there, how MySQL knows like that grants is not available for that user. That kind of check from where it will get like that. I understood my questions.
Yeah, so this information is actually stored in your MySQL database. For
yeah.
example,
Yeah, MySQL database. See, that MySQL database objects will be loaded into the memory whenever MySQL daemon started.
so this
Not in,
information's actually not, I would say these are not in the memory. For example, if you see physically
mm,
where lib MySQL, you will see the physical file for this. This is your mysql.ibd is there, right? So
right.
this all your MySQL tables will be stored in the this file only. Okay, but whenever it is needed, for example, select user, comma not user. Let me do select star. Select star from mysql.user where user equal to test. Okay. So I'm checking so for each and every user, you will have this entire entry here. Okay. So for example, for the test user, whenever you are trying to log in the MySQL, it will validate this table first, the user is exist or not. Okay.
Yeah,
If- Yeah, once your user is exist, then it will validate the password here. From the authentication string, you have the
correct,
hash.
correct.
This is your password. This password will be validated. Once your authentication is successful, then when you are trying to execute some query, it will verify all the privileges here. Okay. So
Yeah,
for example, this user only have the select privilege. That is yes. The rest of all the privileges are no, no, no. Right?
actually,
Similarly,
normally in other technologies, in Oracle or somewhere in Oracle in other technologies, these tables permanently stored in the disk. Okay, whenever you start the engine, whenever you
hmm,
start the database, okay,
hmm,
whatever we called as these all tables called as the dictionary objects, dictionary tables, whatever
hmm.
there in the MySQL database. These tables will be loaded into the memory. Normally in Oracle, we will give in a SGA. So, for example, SGA, we give some 3 GB or 5 GB. If you give 1 GB,
Hmm.
your database won't perform, it will be hanged, because for that 1 GB, these all dictionary objects will be loaded into the memory, that it will
Okay.
occupy or it will capture that complete 1 GB memory. Whatever these dictionary objects, whichever you shown me the table,
Hmm.
right?
So
These
you
will be
mean,
stored in 1 GB. So it will, user operations, it won't be performed, it will be slow. So
okay,
if
so
you give 5 GB, then what it will do, 1 GB it will occupied by the dictionary objects. Remaining 3 GB or 2 GB, it will use for your parsing and this one optimizing. These all operations.
so you mean this memory you need to allocate manually, right? In
Yeah, no,
Oracle.
some memory actually, some even I don't know here. You are saying, you said earlier, for each thread there will be some memory will be allocated. So by
Yeah.
using the thread operations, actually it may allocate that memory, and then there for each thread these operations will be performed like that. Or thread based, it will be allocated this memory or permanent. That I'm not sure actually. Even I don't know.
No, no. Actually, we have the parameter thread stack.
Mm,
Okay. So this is
mm,
the minimum memory which will be allocated whenever the thread is getting created from your server.
correct.
Okay. So this memory will be used to validate all these things. But we,
Mm.
so far, what I remember, we don't have anything like we can allocate some memory for this um uh dictionary thing.
Parsing and
Yeah,
optimizing
yeah,
dictionary.
yeah. But we have this parameter thread stack. So this is the minimum memory which will be allocated for each and every thread when it is getting created in the MySQL. So it will be used this memory for this all operations.
Okay.
Yeah, yeah. Cool.
Mm.
Let's move on then. The next one, where is that diagram? Yeah, so this is done. Then it will comes to the engine. Okay, we have different types of engine in the MySQL. So you can validate by. So all the engines are pluggable. Okay, so currently it is displaying for 11 engines here. Okay, each engines have their own operation. But the command itself, it is mostly same. You don't need to execute different commands for different. That is not like that. Command is same, but each engine have different purposes. Okay, and mostly nowadays we are using the default InnoDB engine. Okay, because yeah, you can see some description here as well. It supports transaction, row level locking, foreign keys, all these things. Fine. Anyway, we will see this. We will dedicatedly see this architecture, DB engine architecture, everything. So we will cover more there. Okay. So this engine will define there are two things uh, in optimizer will define the query execution path. Only that thing. Okay. What index needs to be used. That's it. Okay, but how to do will be decided by the engine. What to do will be decided by the optimizer. It will define the plan and all these things. But how to do that will be defined by your underlying storage engine. Okay, that engine operation. So we will see the entire transaction flow in your DB engine architecture. So we will understand this better. Okay, fine. And once this pass this layer, once the engine does the job, then MySQL at the end durability, right? We need to write the transaction in our hard disk so that it will be available for the lifetime, right? So then when comes to the disk part, that is file system, and we have some files. This that is the physical file that we will see now. So here you can see this is the flow actually. I'm not much expert in the Linux thing, that OS thing, but this is on I got from one of the Linux article. So this is how the flush, I mean, will happen, the flow in the file system layer. First, once the operation everything is completed for the query, finally the results needs to be stored when it comes to read or write to your disk. First, MySQL will request to it will give the request to read or write. Then your VFX, which means virtual file system, that is Linux kernel, that provide a interface that is actually the common API for all the file system, the virtual file system one. Okay, provide a interface for MySQL to interact with any mounted file system. Okay, then it will come to the file system level, whether it is ZFS or ext4, XFS, whatever. When it comes to the file system know where the files and directories are stored and how to access that. Okay, that is about the file system layer. Then we know that, right? Each disk we have the blocks, block, and this block size will be based on your disk, I mean disk type, right? So, and disk everything we need to tell the block, then the block will be written in your disk, right? So then the block layer, what it will do, it will, I mean, receive your IO, which needs to be written in your actual disk. It will convert the IO request to the commands that storage device understand. Okay, that will happen in the block layer. Finally, your disk will be written with the, I mean, with the command created by this. Finally, your data will be written here. So these are the different layers which happens in your file system level. Okay, maybe you can go through it more on the. I will share that link. That is actually very insightful to understand this in the file system level. Okay, I will share that. And once this is done, we are good, right? Your transaction is finally written in your disk. So this is about we are connecting. We have different connection, I mean non-SQL and SQL interface, then query parsing, authentication, I mean access validation, optimizer is defining the plan. Then your query will check whether the cache or buffer anything can be used to run the query in the memory completely. Then once these all things are done, it will comes to your storage engine. The query will go through the entire storage engine flow. This we will see. Okay, that is the engine architecture. We will see about this. And once this is done, finally it will comes to our file system. Then finally it will get stored in your disk for the durable thing. And these are the different files and logs. These are all involved in this in your disk layer. So mostly what you will see there is this is a data directory, right? So these are all the different files. So we know whenever I am creating one database, it will create one file. For example, create database test. Okay, I created the database test, and if you see, it will create one folder. Where is that? It will create one folder for your each database, and within that, use test create table t1 id int. Okay, so whatever you creating the table, then what happened within the test, it will create its table space, which is the t1.ibd. Okay, t1.ibd. So this ibd file will contain your data as well as index. Okay, your data and index both will be data pages and index pages. Both will be stored in the ibd file. And this you can control with one of the parameter, which is select at InnoDB file per table. Okay, so this is the parameter. which means whenever you are creating a new table, it will create its own table space. It will create its own .ibd file. Okay, let's say if I am disabling this set global, this is now dynamic parameter. Now I disable it. Okay, previously it was on, now I disabled it, and I'm going to create one more table t2. Okay, so use test. Now I created T2 inside the test database. Now if you see T2.imd is not there, right? In your physical file, it does not create its own IBD file because your table is actually exist, but it does not table T2 table does not create its own table space because we disable this parameter InnoDB file per table parameter. Now you have the question, then where the table will stored, right? So when you disable the InnoDB file per table, all your tables will be stored in the IB data one. Okay, so this is the system table space. Okay, this is the .ibd is the individual table space. IB data one is the system table space. Okay, so when your file per table, InnoDB file per table is disabled, all your entire data and index, everything will be stored in the IB data one, which is the system table space. Okay, now I'm just enabling it back. Okay, and I'm just enabled and I'm creating one more table, T3. As usual, it will comes under CD test, right? Test. So here you can see t3.ibd is created on your created with the dedicated table space, individual table space.
So that means if our table T1 is increased to 50 GB, all of that data will store in that .ibd file, one ibd file. It will not create the like another ibd file if the data is large.
Yeah, correct. You are correct. Everything will be stored in a single IBD file until
Okay.
you do partition or yeah. So if you have the partition, then your IBD file will be splitted into different physical files. If it is a normal table without any additional thing, then every data will be stored, even it is 1 TB or 2 TB or 5 TB, 10 TB. It should be stored in a single IBD file. But you need to make sure your file system is allowed that size because let's say if in your RDS environment, I think the 4 TB is the maximum allowed for per file size. So, right. So your file system may have some limit. So you need to make sure you are not reaching that. Apart from that, your whatever big your table, that should be everything will be stored in a single IBD file only until you do the partitioning.
Hi Shri, you told that engines are pluggable. What this pluggable means?
Pluggable means like you can use same command for all the engine. Okay, that is the first thing. For example, if you have two tables, one is from InnoDB, another one is from MySum, you for both the tables that when you are doing you want to rebuild the table means here you will do alter table name engine equal to InnoDB. Here alter table name engine equal to MySum. Okay, the syntax is same. You don't need to change the syntax for each engine. Okay, so the same syntax will be applicable for all the engines. That is the one thing. And within your same database you can have multiple engines. That is something you just need to allocate it. That's it. So
So
plug. Hmm.
in same database, if we have multiple engines and we have saved a different table at a different engine, so how will the MySQL know that where that table is, cause database will be stored in one engine, right?
No, actually, database itself, we do not have any engine allocation. Tables will be allocated.
Okay.
So, yeah, come again. Yeah, you have anything?
Database is a logical name, right?
Yeah, yeah, right.
So, Sektival, question. Let's
Yes.
say I have a MySQL daemon, and then I have InnoDB, and I write some records. Now the records are in disk now. Now I stop my InnoDB engine, and then I restart the InnoDB engine with a different. Uh, Sorry, I restart the MySQL database with a different engine now. Can it read the same records on the disk? Because
Yeah,
now I change engine.
of course. So you can just you can enable multiple engines. Even you can see there are multiple engines are active now. Okay, so when your table is created with one engine, for example, show create table tree of user three, you can see your table is allocated with the InnoDB engine. Okay, so
Mhm.
here your table is already physically stored with the InnoDB engine. So now, if you are asking me that I am going to disable the InnoDB engine, I am going to restart my MySQL, then it will not allow. You cannot access this table. Okay, because your table is already physically stored with the InnoDB engine. And if your question is something like you are going to keep the InnoDB engine and you want to activate one more InnoDB engine, then that is
Mhm.
something possible. Anyhow, because your InnoDB is already active, right? So it will not impact your existing table. And if you want to convert your table from one engine to another engine, that is possible. For example, something you need to do alter table Sri engine equal to which engines are active. MySum is active, right? Let me choose MySum. So this is now converted. If you see the show creatable now my
Mhm.
engine is MySum.
Okay.
So you can switch the engine bit for the table by doing the logical alter.
Mhm.
And yeah, when you have the engine already and you are going to do something with, you are going to disable the engine, but your table is already have MySum, but you are going to disable the MySum engine, that is something not work. But you
Okay.
can switch the engines between the tables.
Got
Make
it.
sense? Yeah.
Yeah. On the disk,
So,
right? If I use for the same record, if I use InnoDB,
mhm.
will it write different metadata than if I use MySam on the
Sorry,
disk?
can you please repeat?
On the disk, when I
Huh?
write the bytes, right? If I
Huh?
use there is this table, same schema, same data. If I write using InnoDB,
Mm.
and if I have similar table created in the other like in MySam,
Mm.
similar table, similar schema, and with same record, are the bytes same or little different?
Okay,
But
so that is a question. Yeah, so that is different. Okay, because in your InnoDB engine, you have different row formats. That is different. You have the dynamic row format, you have the compressed row format, right? So that you can apply. And also in MySam, I don't think that you have such row formats. Okay, the based on your row format, your data size will be different. And if you are using the black hole engine, even the data will never be getting stored in your disk. Okay, whatever you are doing, it will be just like a null. Null. It will everything will go to your null. Nothing it will store in your disk, right? And in your CSV, this data will be stored in your physically. Your data will be stored in a CSV file, right? For example, if you see this CSV, the used table type does not support auto increment column. Okay, so this let me create one table quickly. create table T1 ID int name worker 16 engine equal to CSV. One second. It is activated, right? Let me create the table first, then I will convert. Alter table T11 engine equal to CSV. Show create table T11. Okay. Alter table T11 modify column ID int default or integer, right? Or default 1. Similarly, for the name column, name worker 16 default is something like this. Okay, show create table, and now let me convert to CS. Oh man, the storage engine for table does not support. We already converted, right? No nullable column, right? What is next? Default 1. The storage engine for the table does not support nullable columns. We do not have nullable column. Let me try to insert some data. Insert into T11 values. Okay, let me try. Now, oh man. So anyone have any idea? What is this error? We already we have two columns. They are not nullable, right? With default value we change to some value here and there. T1 engine equal to CSV table does not support nullable column. What does this mean? Let me search. So alter generating the table before altering to use engine, you must use alter table to change the to not. Okay, we need to put not null. Cool. What? Okay. Alter table modify not null and the other modify column not null. Cool, fine. So now let me change to CSV and finally show create table T11. Yeah, so now the engine is CSV. So what I wanted to say, show here is, if you see this value here, this the table is T11, right? Okay, this is on which database? Here. Yeah. So here you can see this table is data is actually visible. You can see 1 comma a. So You got this right. And also size wise, if you see, but for the IBD file, I mean InnoDB engine, the table which created with the IBD file, at least by default it will have 112 KB. Okay, so that is the default it will start. But here you can see this is on the 6 bytes only. If I am creating the same table with same column with InnoDB engine, let's see. I'm just going to convert this to InnoDB. Use heck, select star from T11, alter table T11 engine equal to InnoDB. I'm just converting back to InnoDB. And if you see now that T11 is now changed to IBD, and this is the default value allocated. Okay, so to answer your question, see, this different engines have different purpose. That is the first thing. For example, if you see that real-time scenario, right? When we converted to CSV, what happened? This is actually in the backend. In physically, the files are getting. I mean, the data is getting stored into the CSV file. That also manually we can view it, even without any tool. We can just directly view the actual data from the table table file itself, right? And also similarly, like federated, using the federated engine, you can read the data remotely from the table. And a black hole, whatever data you insert, how much data you insert, it will never get stored in your disk. This is something for your testing. Whatever you want to test, you can use the black hole. But in the real time scenario, we are not using these engines. To be honest, I did have 10 years of experience, but I did not see any people used CSV engine, black hole engine, merge MySM engine, this one, federated. I see some 5 years, 6 years before, one of the customer were using for only one table to create the link remotely between the table. They use the federated. I see this. And MySM initially I was seeing, but nowadays no one is using the MySM. And performance schema, that is like the performance schema we have, right? The database that also considered as a engine here. And memory, NDB, RQ, no, no one are using these engines, but they have little bit features, but still each engine have their own feature, but still the modern tools, technologies we have, right? We have different proxies, so whatever I can achieve through the federated, that I can achieve from the proxies, right? So, and instead of storing the data in the CSV, that is like it's not good for security, right? Whoever have the access to your Linux, they can view the data, right? So I can export the data to CSV from the MySQL. If I want to get the data exported into the CSV format, I can do that from the InnoDB engine itself. So this all can be overwritten. So from my experience, I never see that people are using these engines. They are mostly 99% they are using InnoDB. 1% some years before still, but nowadays no one is using, because the latest technologies we have, right? InnoDB cluster, replica set, Galera cluster, this all enforcing the InnoDB engine. Okay, the if you are going to, and also even for the replication environment, InnoDB with the auto increment is recommended thing. And this modern technologies like InnoDB cluster, group replication, replica set, Galera cluster, Percona XDB cluster, these all things are enforcing the InnoDB engine to maintain the consistency, right? So you don't need to worry about the different engines. Okay, so you can focus on InnoDB. But if in your environment where you are working, if you have any specific cases with the different engines, please bring it up, we can discuss about it. And I also written one more blog while working at Percona. I described all these engines with the examples, so I will share that link. Maybe that would be helpful to understand the purpose of each engine. Actually, these engines are doing magic. Like, let's say if you are seeing this black hole engine, you can see dev null storage engine. Anything you write, it disappears, right? So whatever data you are doing inserting in this engine, it will never get stored in your disk. Everything will just go to the dev null, like it will nullify whatever data you are doing. It will be nullified. So this engine is helpful if you want to test some syntax, you want to test some insert statement, whatever. If you want to test something, then you can use this engine, right? And this merge my sum engine, like two tables you can merge. That is kind of union. Select union two tables, right? It will merge the two tables and store the result. So these have different purposes. What I would say is, but these are never getting used nowadays. Okay, to understand this, I will share my blog. There I explained everything, every of any all these engines in detail, like the same way in the terminal way explained there. You can just go through it. Maybe if you want to discuss something on this, we can do that in our next class. And to answer Charan question, when you are storing the same data in the different engine, whether the size is different physically, yes, because even with the InnoDB engine, you can see the difference. InnoDB support different row formats: dynamic, compressed, redundant. It support different row format. So when you have the different row format, it has their own bytes by default, own length to store the data. Okay, so within the InnoDB also, with the different row format, you will see the slightly different, not much, but the slightly different on the physically your table size. And when you are comparing with the different engines, of course, the size of your table will be different. Okay, that makes sense on this part.
Yeah, that makes sense, Activil.
Yeah.
One other,
So
okay. One other question I
Yeah.
have is, you discussed about transactions and isolation levels and
yeah,
MVCC, right? The other day. Will they
yeah.
be same with all the engines, or only some of them support and some don't support?
MECC, you mean, right?
MVCC, and there will be different isolation levels like read committed, isolation levels. Does
That is.
all of them
Hmm.
support similar isolation levels, or some support some and some won't support something?
It supports InnoDB, right? This is completely for the transaction. So this is MECC. I can sure that is completely for the InnoDB, but this isolation level, it is a database level setting, so that may impact all other engines also. I
So
did
all
not
engines,
experiment with the other engine, but I can check and get back on that.
sure, yeah,
But MECC is supported only for the InnoDB engine.
not other engines.
Yeah, yeah, correct.
Okay, sounds good.
MySQL engines Percona. So yeah, overview of MySQL alternative engine. So I was written this blog. So here you can see all these engines I explained with the detail. Maybe I will share this. You can just go through it. You will feel magic, man. For each engine, you will get surprised on this. But this unluckily, these engines are not getting used. Mostly people are not using. I will share this link. Just go through it. It will give some good understanding on that. Okay, fine.
Yeah, Sri,
Yeah.
when yeah, as part of this architecture, just if you once we this one open the MySQL database, okay, and physically what are the files are what files it will be created there in the directory data directory.
Hmm. Yeah, that's
Can
what
you
we are
open
going
that?
to see. See,
Okay,
yeah, that's what we are going to cover here next.
okay.
Okay, so we just first see this IBD and IB data one, right?
Mm.
Uh, so you got the point of this IBD and IB data one, right? So initially, every table will have their own table space. There, it will store the data and index for the table, and it will also store the dictionary information. Okay, so previously you may aware, we have the .frm file, right? IBD and .frm file for one table, but now from MySQL 8, we have only the IBD file. Before MySQL 8, we had, whenever I'm creating the table, I will see, let's say if I'm creating the T1 table, T1.ibd and T1.frm, both the files will be there. But nowadays, only the IBD file, right? Then you may have the question like, how, where this FRM, purpose of FRM file is, it will store the table information, right? Table structure information, right? Table structure. But now we don't have the .frm file, so where it will be stored is, it will be stored on the IBD file itself. So IBD file will store the data index as well as the table information, table dictionary information. Okay, so now how we can extract it? For example, previously when we have the FRM file, you can just view it, you view that file, right? But here now this is IBD file, we never like we cannot view it directly. For example, if I am trying to view this file free.ibd, this is the binary file, right? We cannot directly view this file. So what we can do, we have one tool, ibd2sdi. This is the tool. This tool will be helpful to extract the dictionary dictionary information, SDI information from the IBD file. It will not extract the data. It will just extract the metadata of your table. Okay, let me show that. So you just need to do IBD2 SDA. This is the tool from MySQL. When you are installing the MySQL, you will get this tool. Okay, then let me do less. Okay, I'm just passing this to less. If you see, you will see the content from your IBD file, dictionary information. Okay, all this version, all these things. If you come to here, this is your column, right? A name column, whether it is auto increment true or not, right? And it will have the data type information as well. So where it is, so this data type information as well. So similarly, it will have the metadata. The second column is the name. For all the columns, it will store the data. So in case if you want to, if you don't have the table structure, but you want to know the table structure, in that situation, you can use this. Okay, you can use this IBD2 SDA. And also still it is not clear, right? You are getting all the informations here, even with the MySQL version itself, everything is available here. 8.4.7, everything is available here. But still, if you want to create the table using this information, you have all the information here in this file. You have all the information to create the table, but to form the create table structure, to form the SQL statement, I would recommend one of the tool uh, that would be helpful. This is the one. This is the GitHub tool, which was designed by Marcelo. Uh, so this tool, the purpose of this actual tool is, what happened? Okay, so the purpose of this tool is, it will convert your SDI JSON to show creatable statement. Okay, so let's try to experiment this. So just clone this repo, just cloning, and I'm just make dir what something batch 5 cd batch 5 and git clone. I'm just cloning that repo. Okay. So this is also very useful when you are, when someone magically like someone drop the table, okay, but you have the backup. You have the backup, like you have the backup of Maria backup or Percona extra backup. That backup size is some kind of 5 TB or something, 1 TB, more than 1 TB, and restoring the entire backup and getting the table structure will take some time, right? If your backup is compressed or encrypted, then it will take some hours. Then you need to prepare your backup, you need to bring the MySQL up. This all things needs to be done, right? From that backup, if you want to restore some particular table, you can just copy the IBD file of the table and you can restore it. But still, for that, you need to be aware of the table structure. If you don't have the table structure, then from the IBD file itself, you can extract the table structure using this tool, using the IBD to SDI tool. That is previous version, that is quite easy. You can get the table structure from the .frm file. But now everything is stored in the IBD file, right? So if any chance, if you are into this kind of situation, you lost the table, you want to restore, but you do not aware of the table structure, in that sense, this tool will be useful. And also when you are just going to this tool, IBD to STS3, that IBD file and PyPlus, that is quite a big JSON, right? There is lot of details. Converting to the creatable statement will take some time, right? To properly do that, this tool I would recommend. There is no inbuilt option so far from this tool, but I would recommend this one. This is the wrapper of this tool. Okay, this is developed. It is available in the Git. So we already cloned this. Okay, so you will get this folder after you clone it. One second, let me admit. Right? After you clone, you will get this. Okay, and you need to compile it. Okay, this is the C program. You need to compile it. The steps are already provided in the. Why my Chrome is behaving differently today? Hmm. Okay, fine. So you can just copy this. Just copy and paste these steps. That's it. See, entering into the directory. Okay, we already done that. And now he is creating one more folder inside that and cd into that folder, and finally he is compiling using the cmake and make. That's it. You need to just make sure you install the gcc libraries on your os, just like I am install gcc dnf install gcc. That's it. Okay, so this is done now. So this is compiled and the tool is available now. This is the tool sdi to DDL, SDA to DDL. This is the tool. Now I am going to execute the same command. Okay, same command what we did. IBD to SDI, and then you need to provide the actual table space which will be located in your var lib mysql database folder and the IBD. Okay, so when I am doing this, what it will happen? It will print the entire long information in the JSON format. But when I am passing this output to this tool, SDA to this tool, you can see this tool will pass the entire output and it will create the SQL creatable statement. You can just copy this and you can execute it. Then you can discard your table space. Then you can import the table space which is from your backup. Right? So this is quite useful tool I found. Uh, when you are trying to get some table structure, want to extract the table structure from the IBD file, then this will be useful. But this tool will not work on the lower environment, like lower version, like before MySQL 8. This 5.7 versions, this will not work because there we do not maintain the SDA information in the IBD file, right? So we cannot extract those information from the IBD file itself. From the MySQL 8, I think this will be the uh, way, like in any situation, if you want to extract the table structure, you can do that. Okay, fine. So this SDI information is also stored in the IBD file. That's what I am coming to say in this data file. So now we are clear about IBD file and IB data one and the this SDI information that is also in the IBD file. Okay, fine.
IBD means database, right? IBD data one means table name, right?
Which one?
IBD means database name. IBD data one means table name, right?
This one you are asking?
Yes. IBD means
No, actually, I am not getting you.
IBD dot IBD means table name,
Yeah,
right?
dot IBD means whatever table you are creating, the table will be created. Prefix, you will have the table name. Suffix, you will have the dot IBD.
Dot IBD data one means
IB data one means that is the system table space, the common table space for all the table. It will store the metadata, and we see one parameter, right? InnoDB file per table.
okay.
Yeah. So
And
if
also,
you
yeah. If I take the backup, okay, it will take the structure of the table also, right?
if you take
Structure
the
and the data
backup,
also will come, right?
correct. That is depends on your backup tool and what option you are using. But by default, it will take the structure and data, right?
So in that case, this tool is not required.
No, that's what I'm telling one scenario, right? For example, if you have the backup with the MySQL dump, if you use the no create schema and no create info, if you use those options, it will back up only the data, not the table structure. And also, let's say you don't have any logical backup, but you have the physical backup like Percona extra backup or Maria backup. You have this thing there. Let's say your backup size is quite huge, so extracting the backup and importing, creating the new MySQL instance, restoring there will take some time, or that is something not possible for quickly. And in that case, if you want to recover any table quickly, we have the option to import the table space for the specific table. So you can just copy that particular IBD file to your target location, to your MySQL server, and you can import it. But to import it, you need to be aware of the table structure,
Okay.
right? For in that kind of situation, you can extract the table structure by using this approach.
Okay.
Yeah, instead of restoring the entire backup and getting the table, you can just extract the table structure from your IBD file, then you can just import it, right? It will.
So in backup restore, we are going to test this scenario, right?
Can you repeat, Manoj, please?
So in the backup restore section, we are going to test this scenario. Are we going to test this?
This import and discard thing that we will test it while we do this physical backup thing,
Okay.
like Percon extra backup, or yeah, we will see the Percon extra backup. That time we will test it. We will explain that this export and import the individual table space. Okay.
Sektivel, just to clear,
Yeah.
the data files on the disk, right?
Hmm.
Are so Sri.ibd is data file on the disk, or
Correct.
the scheme or the structure of it on the disk?
Sri.ibd have the structure, index, and data. All the three things.
Okay, so if I just take backup of this, I can take this to any other InnoDB database and then just reload this data, this table, right?
You can do that. But
Okay.
for that, you need to aware of the table structure, right? If you just have this free.ibd table, you just have this file. Okay. Now you want to import somewhere. But how you will do that? You will need to know the table structure, right? Without that, you cannot do that. But yeah, to get the table structure, you can follow this approach. Then you can import it. You can use this file.
So table structure is also present in Sri.ibd, right?
That is correct. That is correct. Yeah, you will get all the information from the free.ibd itself. Correct.
Table structure and data also both. Okay.
Yeah, data and index, all these three.
Okay.
Cool.
Sri, can you open that one? Go to my data
My
and just
which one?
That base directory, data directory.
Okay, okay.
Just want to look that what are the files are available.
Yeah.
Okay. Here, apart from the bin logs,
Hmm.
so what are the basic files? It will be this one. See, MySQL.ibd is a database name, right?
Yeah,
Though
that
it's a
is for.
database name, it will create as a file, data file. Sorry, it's created as a table.
Actually, MySQL previously in before MySQL 8, all the tables under the MySQL database were MySum engine.
Okay,
Okay. But from MySQL 8, those tables are converted to the InnoDB engine because from MySQL 8, we are completely moved to InnoDB. So the
InnoDB.
system table
Correct.
is also converted to InnoDB. Okay. So this MySQL.ibd is the common table space for all the MySQL tables.
All the so
Yeah.
for this no directly it will come as a table.
Correct. Correct.
Okay, that is one thing fine. And for system table, IB data one
One. Correct. That is the
and
common.
two,
Mm.
and both are two. So what about this undo one, undo two?
So if the that's what see we have these undo logs here, redo log, right?
Okay,
So what I would say is let's go one by one.
okay,
Okay, so
okay.
we have
Then we
all the
can
stem
see.
folder, everything is we have here.
Okay, okay. Yeah, yeah. Go ahead.
We can go one by one. So is that
Yeah,
fine?
yeah. Fine, fine. Yeah.
Yeah, yeah.
Shaktivel, is that the catalog? That mysql.idb file is the catalog file, which contains all the statistics and stuff.
Sorry, I did not get you, man. Can you come again?
Is that mysql.idb?
IBD,
Is
yeah.
that the catalog? Yeah, is that the catalog data that is stored there?
No, I don't think
No,
it is a catalog
no,
file.
that is those all are the system databases by default databases when we install the MySQL.
Okay, okay.
Yeah, so
Yeah,
within
means, MySQL database contain all our user information.
Okay.
Yeah, whenever we create a user like our application user or any user, everything will be recording on the MySQL database.
Got it.
Sir, one more
cool.
doubt. Last. Can you
Fine.
please go notepad?
So now before going to this, I mean, see, I can just tell what is undo log, what is redo log, but that is something not going to that much helpful to understand this, right? So what I am thinking is, let's cover this InnoDB architecture. So there we will see all this information. For example, yeah. So here you will find all these files: double write file, change buffer, log buffer, IBD, table space, IB temp one, redo log. So everything is available here. So what I am thinking is in the next class we will go through this entire architecture, and that time when we see this, let's say when we come to this undo log, we will see what is undo log and in the physical thing. What do you think? So I think that would be helpful.
Yeah, right. This
Because
will be
now
helpful.
if I am telling that like what is undo log, I think that may be confusing. So I think we will see this, I mean, table space related files in our next class, the complete InnoDB architecture in our next class. So, but now what I would like to cover is I want to go through these files now. These are not come in part of your InnoDB architecture. Okay, so let's try to cover this now. And this temp table, this all things we will see in the next session through with the InnoDB architecture. Okay, that is fine. So we can quickly go through it, these things now. So guys, what do you think?
Yeah, good, good. Yeah, go ahead.
Yeah, because if we start this InnoDB architecture, it should at least take 1 hour. So I think this time we are already approaching, right? So I want to continue with this. Okay. Fine. So let's see about this binary log. So you might already aware of this binary log, right? So this will record all the database changes, whether it is database or whether it is structure wise, or you are creating the user, modifying the user. So whatever changes you are doing in your database, everything will be recorded in your binary log. Okay. So you have the different filters available in the binary log. You can, from the bin log side, you can do binlog do db and table, ignore db table. Okay, there's whether you can decide whether how what was the database needs to be recorded in the binlog, that we will see in the replication session. Okay, but by default this binary logs will be available in your data directory. And this binary logs, if you are seeing this, it will not visible. Okay, so we will see more about the binary log in the replication session. Okay, so this is like a kind of binary thing, you will not get the right data by manually viewing. So we have the utility which is MySQL binlog utility, uh, base 64 output equal to decode rows. I'm adding verbose to verbose and now passing the binlog file, just passing to less. So here you can see, so you can, the MySQL binlog is the utility that using that utility you can decode your binary log and you can view the content inside the binary log. And the MySQL binlog utility also can be used to take the backup. Okay, backup of your binary logs. Okay, you can directly stream connect. You can remotely connect the MySQL and you can stream the bin logs to somewhere in case if you want to take the backup. As you see here, this alter table statement, right? It is exists here, and uh, what is this? Yeah, this insert statement we did, right? Insert into here. This is exist here. So these are the not the exact SQL statement. These are the events. Okay, this will be recorded as a event, and each have their own binlog position. Okay, this insert statement is located between this position and this position. So this position, everything will be used on your point in time recovery. You need to understand the binlog structure completely so that you can perform the point in time recovery without any struggle. Okay, so we will go through much more about this binary log. We will see the entire like different formats, binary log, different row images. Okay, so these all things we will also see how to convert the binlog events to sequels, how to do the create the rollback statements, flashback statements to recover the data. So these all things we will be addressed in the replication session. For
But
now,
but for now, I have a question.
yeah.
I have seen the 1 to 8 bin logs are there, right?
Hmm.
So on what basis that bin log gets changed? Like, is there a default parameter or the session changes and that bin log gets changed?
See, there are few things. Max binlog size is there. That is the parameter. Show variables like max binlog. Think max binlog size. Yeah, max binlog size. This is actually 100 MB. Okay. So this is the first criteria. When your binlog size is reached 100 MB, then it will rotate. It will rotate with the name like 1, 2, 3. It will rotate. Okay. That is the one scenario. Then you can manually rotate the binlog like flush logs. So let me show first. Show binary logs. It will display all the available binlogs here. Okay, and if you execute flush logs, it will rotate all the files like bin logs, locally log, general log, everything will be rotated. You can see the new file is created, right? New file is created. And if you just want to rotate only the binary log, flush binary logs. Okay, executing this, it will just rotate the binary log. See here, you can see this new is created. The other scenario is restart. Let me restart. Hmm. Systemctl. restart MySQL. Okay, when I am performing the restart operation, now let me log in and execute the show binary logs. You can see the new bin log is created. Right, previously it was 10, after the restart it is 11. So these are the different way the bin logs can rotated. So you may have the question why this bin logs are exist with the low size, because this is due to the restart. I was testing few things and keep restarting the MySQL, so that is the reason it was created in the different size. And all this bin log informations will be stored in the bin log index file, that is also located in the inside the data directory by default. Index file, see, all the informations will be available here. Let's say in some situation, actually I was into this situation, the disk was grow up to the 100 percentage. Okay, 100 percentage. The bin logs are consuming around, I'm not remember exactly, but something around 150, 180 GB, I think. So apart from that, everything is the MySQL data, uh, data directory files, table spaces, all these things. Okay, so I am unable to purge the bin log in the MySQL. For example, you can purge the bin log for show binary logs. So let's say if I want to purge until this 8, you can do purge binary logs to, executing this command, it will purge the bin log. Okay, previous bin logs will be purged. But that time what happened, due to the 100% of disk utilization, I am unable to execute this purge. I was trying to delete some bin logs by executing this purge command and to recover the MySQL to get the connection, because everything is stalled. But when I'm executing this purge command, that also stalled. Okay, due to the space issue, it is also stalled. So what we decided that time, some 10 to 20 binary logs, we decided to delete manually. Okay, we decided to delete manually, and also we deleted with the rm command. With the rm command we deleted also, but when we are starting the MySQL, it was not able to start that time. Okay, that is something like 5.6 version, I think. MySQL was not able to start. But what happened, we removed manually, but this binlog index file still hold the entries. Right? When I am doing properly with the purge binary log command, it will remove the bin log and it will also update the bin log index file. Okay, during the MySQL startup, it will validate this bin log index file and it will validate all the bin logs are exist or not. Okay, but that time when we remove manually the bin log, we forget to update the, not forget, we do not aware that time this bin log about this index file. We did not update it, and MySQL was not getting started. So then what we did, laterally after some 5 to 10 minutes, we identified this as the, after some Google search, we noticed this binlog index file, that also we need to update. Then we manually edited this file like this. For example, we just manually edit this file like this. Okay, and but this is not recommended, but you need to be very careful when you are, whenever you are editing something, the MySQL related files inside the data directory, you should be, it is not recommended at all, but you need to be very careful whenever you are doing something. And now I can remove it. Okay, so whenever I'm removing it, I also need to update this binlog index file. It will keep track all the binary logs. Okay, so this is one, the post that incident only I was come to know about this index file and how it is working actually. Okay, so yeah, just start to share. That's it.
So that means if we need to do this, we need to like remove the first one, right? The first inserted binary log. Because if we remove the latest one and if our system is in replication, that will break the replication, right?
Of
No,
course. So
like, no,
yeah,
we have to check the replication side binder log which is current. Before that we can remove.
so
So if you
yeah.
are like if you
Mhm.
are Oracle DBA like archive logs, we can remove archive logs before sync, right? Like data guard said, like till the archive log number, and before that some before 10 logs like that we can remove.
Mhm. No, in Postgres also I do that. I remove, like, I purge the archives.
Hmm.
But this is the same
Yeah, we have
situation,
to.
I think. Yeah.
Yeah, we have to check the replication set bin log.
Mhm.
Before that, we can remove.
Okay.
And also, Sri, in 8 versions, like 8 and above, if you remove manually, also we can restart the MySQL
Yeah, yeah,
without updating the binary, bin log index.
yeah.
Because I
So
did many times.
that will just print the warning in your error log, and you will still able to
Mm.
start the MySQL. But in the previous version, it is not the state. That's what I mentioned,
Mm.
right? It was 5.6 version.
Mm. Mm. Nowadays, nobody is not using it.
Yeah.
Sir,
So removing the bin log, actually you do the show slave status, right? To check
Yeah,
the.
yeah, definitely. Otherwise, we have to restore, like we have to rebuild the slave.
Yeah, yeah. So you need to make sure there
Mm.
are few parameters, like you need to check the relay master log file and the read
Mm-hmm.
master log file. Okay, so relay read master log file means what is the current bin log which is updating by the master, which means primary. Relay master log file means which is the current binary log which is processing in the replica from the master. Okay, so yeah, I
No,
don't want to
So even if our system is not in replication, we cannot remove the latest one, right? It will create the
we
problem.
cannot remove. We cannot remove.
So if
uh,
you
Yeah.
want to do something like that, you can do one flush binary log command and you can remove that thing. You need
so
to at
sir,
least keep one bin log there, right?
Same, friend. Same like in wall logs in Postgres.
Yeah. I got it.
sir, my current binary log is .08, right? If I
Uh,
want,
No,
if
current is
No,
011.
10, 10,
sir,
11,
if
11.
I want to remove 10, I need to go
You
with the
can.
dot index file and remove until dot 10, right?
No,
no,
no.
no,
You
no,
can
no,
use
don't
purge
remove.
command. You can. No, don't do like that. We can remove through purge command. That is the
Yeah, you
best option.
If
should
you
do
have
through the.
space, we can do through purging. If I don't have space, I need to go index file and remove until
See,
the.
in any case, if your MySQL got stuck due to the disk concern and removing the binary log is the only option, then only you need to think like consider removing the binary log. Okay, manually. It is actually not recommended to do anything. Removing manually is not recommended. If you want to remove one table, do drop table. Okay, if you want to remove the binary log, execute purge command. Okay, if you want to remove any partition, drop partition. So everything you should manage through the MySQL client. Okay, but at any cases, if you want to do something manually, in any rare situation, you are in some critical situation to recover the database, then you need to aware what you are doing. You need to make sure you that is not going to impact. And still here also, what I would recommend, instead of removing, you can copy or you can move your bin log to different partition, right?
Okay.
That time we do not have the option, but that is also one of the option you have. Let's say apart from your MySQL data directory, the other partition, if you have some good amount of space, just move it, right?
Mm.
Uh, because some binary logs are crucial, right? Binary logs are very important for two things. One is replication, and the another one is recovery, point in time recovery, to perform the point in time recovery. For both of these, binary logs are very, very important. So your
Or
question
else
is
can
like
add the space also, right? When it is 100%.
adding the spaces, something possible in your infra, that is good to do. Yeah.
If if your servers are running on cloud and if you have the add the manage disk role, then you can do.
Yeah, yeah.
If my database is down due to the 100%, if I add the space, we can start. It will start or not?
No, you no need to start automatically. Like once space is released, right? Automatically your processes will start. No need to restart.
In on-premises also.
Yes, no, on-prem you have to do because that will be taken care by Linux team, right? If cloud and if you have the role, adding a disk role, then no need to restart the server. So there is like bare metal and cloud. So bare metal downtime is required, increasing the space.
After that, if I want to start being a DBA, manually we need to start or it will
Yeah,
not start.
it will start.
Okay. Okay. Okay.
Sectual.
Yeah.
We do have redo logs or val logs in MySQL as well. Why do we need binary logs? Then we can
Actually,
use them for replication and point in time recovery because val also holds everything.
no, actually here I'm not aware of the val log on the posters, but here redo logs serve different purpose and binary logs serve different. Okay, so redo log is completely for your crash recovery thing. For example, let's say MySQL perform every operation on the memory on your InnoDB buffer pool, right? Whenever you are writing, modifying something, that page will be copied from the disk and it will be updated in the buffer pool. Then it will be modified, then it will be called as a dirty page, right? So similar simultaneously when you are doing multiple transactions, everything will be stored in the memory. At some flush point, checkpoint, it will be flushed to the disk. This is how MySQL work. We will see that. But here, what happened in case if your MySQL is crashed, you were in that situation, the modified transaction, I mean the transaction committed which are in the memory will be lost, right? So to avoid that, redo logs are located in the disk. So what MySQL will do, whenever the transaction is getting committed on the memory, it will also return in the redo log. Okay, it will not upload in the actual IID file table space. It will be written in the redo log. So in this case, then only you will get the commit. Okay, once your transaction is committed and written in the redo log, then only you will get the commit signal in your terminal, like front end. Then only the transaction is actually committed. So here in this case, in case the MySQL crash, I will lose the transaction from the memory and the buffer pool. But still, when I am doing restarting the MySQL again, it will scan the redo log and it will process all the transaction which are written in the redo log and it will apply it in the actual table space. So that time at the end when your MySQL is getting started, your database is consistent. Okay, so what I'm telling is redo log is something for it will maintain the transaction just for your crash recovery thing. Once the transaction is applied in your table space, then it will be remove the data from your read log. Anyhow, we will see this in detail in our InnoDB architecture the next session. But yeah, here the purpose of the binary log and read log is different. What binary log will do? Binary log will record all the changes. Once it is committed, it will be written in the binary log as well. Uh, but here the thing is different. So this will just come in the picture when you are having the replication and the what is it, point in time recovery thing.
So
You
where
can
is the
view
redo
the
logs here? Redo logs are in memory or
read
those
logs
are
are
in.
in the disk inside this folder where it is redo this one
Oh,
inside this folder. And you cannot view the data from the redo log, but you can read the data from the binary log. Okay,
mhm.
redo log size is restricted, so we can have any size, but usually we will maintain some 5
So can
GB.
we check that one? Redo logs number, it would be there. Can we go to that folder?
Yeah, I will
Which one?
show that. But yeah, this is something I am telling why we are having both, right?
Yeah,
Like Karan were
both,
asking,
both,
right?
both.
Yeah, once again. Mm.
Oh, so okay, these are this many.
These are all the binary logs and the redo logs by default size is 100 MB.
Okay.
Almost all same structure for Postgres also.
Yeah. So here, this is why I am telling is the question was like why we are, I mean, we can use the redo log for same purpose of binary log, right? But that is not something possible. Because binary log you can have it more. The both of these files are serving the different purposes. That is the first thing, and that you cannot read the read log content. There is no tools, nothing available. Okay, based on the design, so that cannot be used for the replication because how the replication is happening is replication.
I,
Uh, yeah, it will read the binary log and decode it, and it will apply the events on the replica, right? But that is something not possible with the redo log. The purpose of the files are different.
Okay, in binary log, only the committed transactions will be present, right?
Correct. So
Okay,
that is
but
also, I would say, there are few settings. Even for the redo log also, we have one setting which is InnoDB flush log at transaction commit. So we have three values for that: 0, 1, and 2. So 1 means for every transaction commit, it will write and flush the redo log. So you are completely asset. 0 means for every second it will write and flush, which means within a second there may be some more than many transactions, right? More than 1,000 or like how much transaction can happen within a second. So if you have that setting to 0, then you may have the chance to last the transaction, right? When you have the 2 value, the another value 2, then every second it will write but not save, not flush. Okay, that time also, if your OS cache is not optimized, not written the file, then you will still have the lost the transaction. But yeah, no worries. We will see this in deep tomorrow. Not tomorrow, on our next session, next class. Both of this for the binary log. Similarly, we have the sync underscore bin log. Okay, that is the one of the parameter. If you have one for every transaction, it will write the binary log. You can set different values like 10 or 100. You can set any value for that. You can also set to 0. 0 means for every second it will write and flush. 100 means every 100 transaction it will write and flush. So this all, or we can control it. That's what I would say. For the optimized setting,
any
I
other
mean
logs there? Again, you are saying something else. Redo log, binary logs.
undo log,
Oh, undo log.
yeah. We have other files like double write buffer. We have temporary table spaces like ibtempo and ibt files.
Yeah, these all are we'll discuss in InnoDB structure.
Of course,
InnoDB
we will see,
Okay.
of course, yeah. We will see in some examples, so you will get understand better.
Okay.
Yeah. Cool.
And so, by default, what is the value?
For which one, Vishwanath?
Redo, redo. I mean,
Uh,
it would be 1, 0.
yeah. It should be one man that will provide the complete asset. So it should be one. So select attach InnoDB flush log at TRX commit. Most complicated parameter, man, in MySQL to remember.
Yeah.
Yeah, it is one. Cool.
In most of the cases, it will be 1 only, right?
Sorry.
Like in most of the cases, it will be like by default, it will be
It is
1.
strongly recommended to keep it one on your transactional environment. Okay, but having it one will degrade the performance because every transaction commit it needs to spend some IOPS in the disk, right? It needs to write and flush the disk for every commit, right? So that will degrade the performance. Let's see, like one means for every one person. One, let's say, I read one example some years before. There is a car. Uh, Sorry, I not know. There is a bus. Okay, you need few of the people needs to travel from one place to another place. So see, one guy is uh for a trip. One guy is traveling from here to there means it will take some 5 minutes for one person. So for the 100 person, it will take 100 into five, some 500 time, right? It will be more, but that is the one. If you set it one for each transaction, it needs to go to disk and flush, write and flush. Okay, but if you set it zero, which means all the 100 persons are going to the bus, and in a single trip you are delivering everything. That is the thing when you set it zero, which means it will club the transaction within a second. How much transactions are happening? Maybe some 10,000 or 15,000 transaction. It will take an entire transaction and it will go to the disk and write and flush. Right. So in that way you will get the performance. But uh, but uh, but you are not meet the asset in case of any crash happens. Until that it is okay. But in and if any crash, OS crash or power issues, anything happen, then you will get the chance of losing the transaction. So that is completely not recommended for the banking sites or the crucial OLTP environment. The recommended setting is one. But we some replicas recommend to keep it two or zero, because when you set it up zero, you will you will I mean your replica will be boosted. Like it will quickly solve your replication lag. Okay, so yeah, we will see that in the coming sessions about it. So this parameter is very important to meet the acid and the performance wise, right?
Thank you, sir.
Yeah. Yeah. So anything else? And also, as yesterday I mentioned, right, tomorrow I have this family temple festival entire day. So planning to take off for tomorrow. But instead of tomorrow, planning to have it on Monday. Let me see. I will update you. I will update on Sunday before 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 8 o'clock or 6 o'clock in the group whether we will have the class in Monday or not. Okay. Mostly I will try to get it on Monday. But yeah, anyhow, I will update in our group chat. But yeah, tomorrow we will take off.
Let's see one quick question.
Yeah.
You said if I create any database, for example, test database, it will create with like in that some T1, T2 tables, it will create T1.ibd and T2.ibd. So if I set that, you said one parameter, right?
InnoDB file per
InnoDB
table.
file per table. If
Yeah, yeah.
I set it to zero, so
Hmm.
then it will like whatever the T1.ibd, T2.ibd, it will not create. It will directly dump into ibd data.1.
IB data one, yeah. But see, when you are setting this now, it will not impact the existing table. Okay, the new table will be affected.
So till whatever that parameter got changed, after that everything will be dumped into the IB data one.
No, it will not dump. That's what I'm telling. See, when you are creating the table with the InnoDB file per table equal to one, then your tables will be having the dedicated individual table space, which means .ibd file, right?
Yeah.
Yeah, so let's say I created some tables T1, T2, T3, T4, T5 with InnoDB file per table equal to 1. That is already created. So all my five tables are having individual table space. No, sorry, let me explain here. Use herc. Okay, show tables. Hmm. Show tables. So we have these tables, right? So if you see this inside herc, I have the dedicated IBD for all these 4 tables, right? Now I am changing set global InnoDB file per table equal to 0. Previously it is 1. Now I'm changing to 0 and I am reconnecting. Okay. Now let me do create table T5 like Sri. Okay. And T6 like Sri. And T7 like Sri. T8 like Sri. T9 like Sri. One more table. T10 like Sri. So if you see now, I have created multiple tables, right? If you see show tables, it is displaying all the tables now here. But if you go to your physically, if you go to your database folder, those tables are not exist here. And the tables which are created before InnoDB file per table equal to 0, right? Before they are still there. They will be there. This once you change that parameter, it will these tables will not migrated to this system table space. This will be there. Okay. The newer table which you are creating, that will be stored in the IB data one. Make sense?
Where is
Hello?
remaining files we created? No, it will be stored in IB data, right?
Yeah, this now these tables are stored in the IB data one. Correct.
So where is that file here?
It should not be in your database folder, right? That is a common system table space. It should be in
System.
your data directory, IB data one. And the problem with storing everything in the IB data one is if you are dropping the table, still you cannot reclaim the space from the IB data one. Let me show one example. For example, now we have this table, right? Select, sorry, yeah, select star from T10. T10 is created inside the IB data one. Show create table T10. Okay, these values are here, right? Auto increment default current timestamp. Okay, now let me do some insert on this table. Insert into let's try to increase this size. Currently it is 12 MB, right? Let me try to increase this size by writing on T10. T10 is reside on this IB data one, right? T10 T10 just name values some name insert into table name. Okay, name should be in the bracket. Okay, so anyhow inserting this will not growing the size. I need to do some bulk insert. I think this table have some data. Select count of star from, yeah, this have some data. Limit 1. Let me check how many columns we have in this. Okay, cool. Only this. Fine. Now let me do T10. How much? This is 16, right? Let me modify this first. Alter table T10. T10 modify. I'm just increasing the varchar length because currently this is 16, right? It will not, this varchar length is more. So I'm going to insert this data, all the data to this table. So I'm just increasing the varchar length to 500. Alter table name, modify column name is name, right? Yeah. So now the varchar length is 500. Now let me insert into T10 name uh, select name from select name from this table. Load one. It has around 3 lakh data. So yeah, see, these are all insert. Let me do one more insert. So now the T10 table size should be increased, right? Select count of star from T10. T10. Yeah, it is almost around 10 lakh. Let me do one more round. Fine. So now you can see this select count of star, it is having around 15 lakhs data, right? So it should be some good amount of space. Now let's check. This T2 is reside on which database? Herc, right? I think Herc. So if you see inside the Herc, T10 is not there because T10 was created in the IB data 1, IB data 1, right? So IB data 1 size before the IB data 1 size is 12 MB, right? We noticed that. Yeah, 12 MB. Previously it was 12 MB, but after we insert all this data, now let's check the IB data 1 size. IB data 1. See, it is now 140 MB. Right? It is grown because um, this table is stored in the IB data 1. Now let me drop this table. Drop table T10. Okay, I just dropped the table, T10 table. That is the one, that Jane table we created, right? If you see, after dropping the table, still the size of this IB data one is 140 MB. This is one of the very big drawback of storing the data in the IB data one. This file will never shrink. Okay, even if you drop the entire database, this file will not shrink. Okay, so that is the one of the very big drawback of storing everything in the IB data one. At least if you
So
are
there is no other option to like reclaim this space.
yeah, so the only option is you need to perform the logical backup and restore.
Okay.
You need to perform the logical backup with MyDumper or MySQL dump or shell utility, whatever. And so actually I worked on one project. Their size was 12 TB, and this IB data one file size is around 11 TB. They stored most of the tables in the IB data one. So we created one more server. There we enable the InnoDB file per table. Then we made the backup, logical backup. Then we restore from here to there. So when we do the logical backup restore with the InnoDB file per table equal to 1 on the new server, it will get created its own table space. Not everything will go to the IB data one, right? Every table will create its own IBD file.
That
Then
required downtime, right?
sorry.
That
No,
required
no.
downtime.
Actually, we create that operations. Everything was happening in the current server only. In the new server, we restored there and we created the replication from here to there.
So
Then,
so so
yeah,
after the restore, that IB data one file will be stored into the IBD file. Is that the case?
yeah. IB data. See, because we are restoring the logical backup on the fresh server, right? Fresh server with the so fresh server means there the IB data one is already 12 MB, the default size, right? And I already enabled the file per table equal to 1, which means whenever if you are going with a physical backup, this is not possible, which means physical backup means like a Percona extra backup or Maria backup. There you will copy the physical files from here to there. So in that case, this will not work because in that case, physical file means your backup will contain the same IB data one file here. You are just going to restore there only, so it will not work. But when you perform the logical backup, you know that logical backup, what I mean, right?
Yeah, right.
MySQL,
I know.
yeah,
And
yeah.
MySQL doesn't have like a by default physical backup. Like we need to use the like extra tool, like Percona backup or something like that.
Yeah,
We
yeah.
cannot take the physical backup directly. There is no utility for that, right?
For you
Taking
mean
physical backups
for MySQL you were telling?
for MySQL, yeah, right?
Yeah, yeah.
Is there
You
any?
have the MySQL Enterprise backup, but apart from that, yeah, MySQL Enterprise backup that will be doing the what this physical backup only. But apart from that, I don't see any tools. You need to go with the Percona Extra backup. That is one of the open source tool available to maintain the backups, physical backups in the MySQL environment.
Mhm.
Okay, so logical backup in the sense, it will in your backup file, it will have the logical content. So let me perform one quick backup here. Why it is not working, man? MySQL dump. Okay, I don't have free database. Sorry, Herc. So I'm just performing the backup for the Herc database. Okay, Herc database. So if you see the backup file, this is actually the logical backup because your backup file will contain the logical content, not the physical file. That will have the logical content, which means
The
it will
actual
have the,
queries.
yeah, create table statement, everything. So when you are restoring this backup in your target server with InnoDB file per table, this equal to on, this create table statement is going to be executed there, right? So that time it will create its own individual table space, right, in your target server, and it will insert the data kind of thing. You got it, right?
So
But we need to set up.
what if on that server too we keep that off and we restore the data?
We restore the data. So once we restore the data, we will need to resume the replication until the
Okay.
point where we restored. From that, we need to start the replication from the IB data 1 to IBD server.
Mhm.
So it might take some time to sync because the data size is huge, right? So backup and restore take some time. So once it is synced, then you can plan the cutover. Like you can switch the application from here to there. Then you can get rid of your IB data one server.
Okay.
That will be see right next sessions how to do.
Yeah, if needed, we can see that also. Yeah. But nowadays, this IB data one is not getting used by that. Everything is now default to the DB file per table. If you are running the traditional versions like 5.5, 5.6, then
Okay.
yeah, you may get into this situation.
Thanks.
Cool. Anything else?
It will be same for MariaDB as well.
Yeah, yeah, MariaDB also.
Thank you.
Sri, this from the my data one, we cannot move the data. Means those table physically to like as that file per table, right? File per table is space. Whatever that table we created T10, T11 like that, those cannot move with a database operation as a physical file, right? From my data one to other.
You mean like you want to move from one folder to another folder, something like that you were asking? I'm
No,
not
no.
getting your question.
Whatever what happens here inside that Arc database,
Uh,
some table we created by disabling that file per table space, right? Then
yes,
it goes to IB data one.
IB data one, yeah.
With any database operation, we cannot segregate, like we cannot move from IB data one to that database, right?
No man, so only way is logical backup and restore. So in case if you want to do perform this on the same database, you can perform the backup from for the particular table. Then you can restore in the same database or the different same server, different database. You can restore there. Then you can swap the table. But anyways, in this way also you cannot reclaim the you cannot reclaim the space from the IB data one. You got
Oh,
my point,
after
right?
after restoring also we cannot reclaim the space.
No, you cannot. See, even we drop the table, we cannot reclaim the space, right?
That is
See, from the IB data one, the only way is doing the logical backup and restore. That's it. So let's
okay.
say currently this T10 table is available in the HERC database. You want to move that table to the .ibd file on the same server means what you can do is you can dump, you can perform the logical backup for that particular table, and you can create one new database like HERC1 or HERC backup, whatever. Then you can restore that table to the new database. Okay, so now the table is in the separate IBD file, but in the different database, right? Now, if you are already on the live environment, you may need to create some triggers. I'm not sure how it is going to work. You need to stop the write for that particular table, but that is also waste of time because still you cannot when you are able to successfully manage to create that separate IBD file, still when you are moving the table to the new database, you need to drop the existing table, right? And you need to move this table to there. So you can do that. This will work, but still after you are dropping, let's say your table is some 100 GB or whatever, after you dropping the table, still you cannot reclaim that 100 GB of data size, disk space from this IB data one.
Okay. So yeah, only option is like a backup restore in a
That is correct, yeah.
new server. Okay.
Yeah, and not only, or you can do some, take some, if your data size everything possible, take some downtime and you can still restore in your same server also after enabling. That is something you can plan based on your environment.
So with this option, that fragmentation also comes in picture, right? Like
That's what
it
I'm
will.
telling. IB data one file will never shrink.
Okay. So performance also it will degrade.
Yeah, yeah, that is correct. It will never shrink. See
So
here,
nowadays, by
140
default parameter is that file for table space is enabled only, right?
enabled, yeah. From 5.6 onwards, it is enabled, yeah. Cool.
Yeah, thank you.
Cool. If anything else, I think we can connect. We will try to connect on Monday. I will update you, okay? And I sent one message in the group, right? If you have some feedback, if you are willing, please send to me.
Yeah, okay.
Cool. Thanks,
Sir,
guys. See you. Bye.
can you please share today notes on the links?
Yeah, I will update in the drive.
Okay, sir. Thanks.
Yeah, thank you.
Mm.